I'm here today with Googler Maciej Machulak and also Thomas Hardjono, and the three of us have been co-humanitarians, as we call ourselves, for working on this technology called UMA, User Managed Access. And so just a little bit about us and the hats we wear. Thomas is the UMA Working Group spec editor, so he's been working on our protocol specs. I've been a founder of the group and its chair since its inception. My other hat is that I'm a Forrester Research principal analyst serving security and risk professionals. And Maciej has been involved in Newcastle University efforts along these lines, and he's now at Google as an intern working along these lines, and we're going to share a lot with you about kind of a new wave of access management. We also tweet at UMAWG if you want to follow us and get news that way. So, the other thing is that we are starting to do some tweet chats, and we've got our second one coming up on March 14th. So if you follow #UmaChat on March 14th for an hour, we'll distribute these slides in PDF form, and they'll have links throughout them so that you can click and learn and whatever you want. But we hope that you join us for the tweet chat. So we thought we'd just take a very simple approach today to what UMA is all about. What is UMA? Show you some demos, give you some reasons why you might want to consider UMA enabling apps and various Google functions, in fact. And we're happy to take questions and offer answers and offer you questions in return pretty much at any time. We'll just make this interactive, right? Okay. So before we actually talk about what user-managed access is, we thought we'd talk to you a little bit about the Street Identity Project, which is something that Google is involved in and demonstrates a user-authorized way of sharing information that's trusted about that user with apps that the user wants to use. And it's basically an OAuth-enabled solution. And why don't I just bring up Maciej to talk a little bit about Street Identity and do a demo.
So hello everyone, thanks for joining. So I'll show a simple demo that shows how Street Identity solves a very specific use case, and we'll then try to show how UMA tries to solve a more generic use case. So in Street Identity, the main idea is to allow an application to retrieve some information about a user, some verified information that can be stored not at Google, not at the identity provider, but rather at the attribute provider. So we'll show a demo how Google facilitates the process, how it facilitates, how it enables the RP to easily get access to information about the user in a very secure way. So I think we can switch. Okay, so since it works, let's take a look at the sign-in process to an example web application. So we currently want to log in as using our Google account to a specific RP. So we go to the RP, we see the sign-in button, we click on sign-in. Yeah, we select the account. And actually, the RP right now asks for some permissions. So it's a typical OpenID Connect flow. This is the approval page where I need to consent that the RP will be able to get access to my basic information. It will have access to my email, but it also will be able to view my verified street address information. And this is something that's new in this flow. I allow access. And, well, I get logged in. This is the user info. This is the information that the RP gets. So there's nothing new in this particular flow. But if we go to another application that possibly has some interesting data about myself, or can have some interesting data about myself, we log into this application and we see that there's a new permission that we can grant to this application, which is view and manage my verified street address information. So as a user, I allow this interaction to happen. And I see that, this application already, for example, has my verified street address. I save it to Google. And the next time I go to the RP, I select the account. And I basically, for example, get access to some sort of a premium service, because not only did the RP get access, get information about the user, but it also got information about the address. So it got some sort of a verified address from the IP that it knows. If I go to Google, so there's some sort of a console And if I log into the console, I can actually see that Google does remember my verified address. It doesn't. Sorry, it only remembers a pointer to this address, so it doesn't hold the address per se, which means that well, there's little privacy implication in these terms. So it only holds a pointer, and if an RP wants to log in, wants to log me, if I want to log into the RP, then the RP only gets authorization to access a specific attribute from an attribute provider. And this is a very, let's say, specific use case. So enabling to get access to a verified information. It looks like OAuth. It doesn't, let's say, necessarily change the user experience. And we can go and see how this is not enough in the, yeah?
So is the OAuth attestation from the Google Street Identity AP being relayed to the relying party, or is Google directly attesting?
No, so Google is only acting as some sort of a broker, so it does not attest the address. It only gives the RP information that there is some sort of a verified information and where this location is located, where this information is located, and it's up to the RP to obtain some sort of a token. And this is where Google comes in. It grants this token to the RP. The RP can later go to the actual application that holds the data. So the data resides in a single location. It doesn't get registered to Google. It's only just.
Is the RP actually validating directly with the attribute provider? If it is.
Yes.
The RP has to be. Yeah, the RP has to be willing to accept the issuer of that trusted street address in order to proceed.
So it isn't relying on Google's.
No, it's mostly just relying on Google to broker the user's authorization of sharing the information. So Google is functioning as the kind of the authorization broker, and the attribute provider is functioning as the issuer of trusted information. You know, and the consequence of this is really, I think, kind of huge, because for a long, long time people have worked on a conceptual model where you have an identity provider, you have relying parties, you have attribute providers that are kind of supposed to be first-class citizens, but we've never come up with a suitably internet-scale solution for how to actually broker the providing of that information. And so this is an example of it working with simple things you can find about the home, like OAuth and OpenID Connect, and obviously agreements that the RP would trust. I think in this case, it's, I don't know what the attribute provider is, but I know that Google's working with Verizon Business and others who have that kind of information because they send bills to real street addresses.
The RP doesn't trust Google at all.
Nope. It has to trust to the extent that the user works through Google to say, yes, it's okay for you to know this, and that's it. Yep. The user has to trust it, yes.
So the downside is that the user can't choose an attribute provider that is their own choosing.
The nature of trusted attributes is that they effectively function as reputation data, right? So let's say, you know, a user can't choose their own credit score. But if they need to provide a credit score to a third party, you can imagine them working through Google, say, to tell Equifax, yes, it's okay to share the credit score you know about me with this third party that needs it because I'm doing a mortgage loan application. So the nature of trusted attributes is that they're third party supplied and not user supplied because, yeah. Yeah, I mean, what's interesting about that is that, you know, if there are multiple issuers that a relying party will trust for a piece of information, and the user, now that you start to have an ecosystem, you start to have a market and where those that data comes from. But it's still driven by who trusts the data.
Or conversely, relying parties only ever support one or two providers.
That's right. That's right. So I think we've established, have you plugged me in again?
Yeah.
Haha. And now I just have to figure out how to play again. And we're playing. So that's a picture of street identity, which is using, again, OAuth and OpenID Connect and a notion of claims that, you know, identity claims that are identifiable in some fashion that you could ask for and get and then judge whether they're good, if they've been signed by the right provider. That gets you thus far and no further. One thing we've learned is that privacy is obviously not secrecy. Privacy should be about selective sharing. And I always think of, like, you know, if you go to the doctor because you've got this terrible problem with a wart, if you don't tell them about the wart and where it is, you can't get your problem solved. So it's not about not sharing at all. There's this wonderful quote. This is actually from some years ago, a paper by Anne Cavoukian, who's a privacy commissioner in Canada, who's very influential, and she had this wonderful quote from this Privacy in the Clouds paper about all the kinds of things you should be assured to know. If you're going to have to share information, you should know how it's going to be used and who it's going to and what purpose it's going to serve and all those things. And what folks who are working on UMA believe is that's all great, but we know that there's something not very empowering about mere consent. And what we want to do when Anne Cavoukian says determine how the data will be used and so on, we want to use the other sense of determine, which is have control over. And that's what we're actually going for with UMA, which sounds like, that's a lot to bite off. We've actually made quite a bit of progress, though, and that's what we're here to show you. So the price for sharing and access is really too high, and there's 3 different problems we see over and over. One problem that we see, right, I'm looking at the future version. One problem that we see is that we have to provision a lot of data about ourselves directly into, say, a local account somewhere that we want to set up at some Web 2.0 provider, whatever it is. So we're typing in data, and we like to describe the problems there as 2. One is you're typing it in by hand, annoying, time-consuming, prone to lying if we don't feel like doing all that, and by value, which means the data goes stale. There's thousands and millions of CRM systems in the world that specialize in holding data about us that they think is very valuable, but it's not particularly, because to the extent that it's volatile, it loses value. Second problem is, okay, we've got OAuth in the picture, and by consenting to have the client side connect with the server side on our behalf using some API, maybe scoped, to some degree, we tend to be installing fairly large pipelines, and this is a fake example of, installing the Kanye West connection where the Kanye West app is going to kill your children. And it's like, allow or deny? Well, if you deny, you don't get whatever the great Kanye West service is. That's the dilemma that a lot of people are faced with. The third problem is that when we do share selectively, and we've got some interesting examples provided by, for example, Google Calendar, where we share between friends and family, it's a royal pain, and it's not very secure. So we have ways of doing sort of friends and family lists. You look at Flickr, for example, and it does have friends and family kind of built-in ACLs that you can populate. The way that you're sharing with them typically involves a secret URL. Well, that works for data that's not very sensitive. It doesn't work for, let's say, health data or tax data. It's just sort of not good enough security. It's security by obscurity. So now let me introduce you to UMA. UMA is a web protocol that is designed to let you control access, emphasis on control, not just consent to access, by anyone to all your online stuff from one place. It's actually a set of exactly one draft spec at the moment. We've boiled it down to an UMA core spec. Doesn't have any encumbrances on it, as far as we know. It's undergoing multiple implementation efforts, and Maciej is going to share with us several of those today. It's currently doing its work under the Kantara Initiative, kind of incubating it there, and we've been submitting IETF internet drafts as we go, with the hope that that work will get picked up either by the OAuth group in a kind of OAuth.next effort, or by maybe a different group. We're not really sure yet, but we're being completely open about this. We have design principles that talk about being explicitly OAuth-based to the extent possible for its technical value and also for its kind of momentum value, to be honest with you. We have goals of being as restful as possible, to be generative in terms of allowing for unexpected reuse in the future. And that's a link there. You can see that Thomas Hardjono's name is ensconced in the name of our ID. And we're just entering into a kind of virtual interop testing phase. So we're getting to the point where we have enough implementations of each of our entities in the protocol to test against each other and see how it goes. So what could you do with the street identity use case if it were UMA enabled? A lot of people have said to us, well, why are you doing this UMA thing when OAuth's right there? And we like OAuth. We're using OAuth quite a lot. We're actually embedding it in several places in our protocol. But here are things that you may want to do when it comes to true access management that you can't do with a self-authorizing function that OAuth provides. Number one, centralize how you manage sharing your street address and whatever other data, content, APIs, access to your services that could be hosted in a lot of different places. So centralized authorization hub is one. Second, you may not want to share your address with an app you're using that's separate from the app that holds your address. You may want to share that street address with somebody else entirely. Like we talk about Alice to Bob sharing as opposed to Alice to Alice. So the street identity demo you saw was Alice sharing with herself, or any one person sharing with themselves using another app. One of the ways to describe OAuth is it's letting two apps talk to each other about you when you're not present. They're doing it on your behalf. So we're talking about Alice to Bob sharing, Alice to employer sharing, Alice to bank sharing, maybe even Alice to government sharing if we get this right. So that's another benefit. Third thing is, by virtue of the way that we control sharing with policies that drive how the authorization hub kind of acts as your authorization power of attorney, you don't have to be present to win. That is to say, if you want to share with Bob, Bob can come along, prove what he needs to prove to show that he's suitable to deserve authorization for access, and you don't have to be present. You can be sleeping, you can be in an emergency room, you can be windsurfing, whatever. Finally, because we're now putting a person in the position of offering to the world data and API access products, if you will, you now have a different role in sharing. It's no longer a matter of the apps work it out ahead of time and you have to consent. Now it's you getting to set policy, which might include things like legal, contractual constraints. So you're in a position not of accepting an offer, but making an offer of access. So just like when you go to a site and it says, click I agree if you want to use the site, we want to flip the tables, and if somebody wants access to your stuff, even if it's a big company, maybe they should click I agree. So I want to bring Thomas up here to talk a little bit about some of the use cases that we have been gathering. So you want to talk a little bit about Project H data and some other use cases?
So the healthcare use case is actually very popular. We hear it all the time. Just to illustrate, a good example, we had a visitor at MIT from Australia. This is John Zick. He was scheduled to come to visit us some months. He had to go to a conference in Mexico. He did. He got sick. He got so sick that by the time he landed in Florida, he had to be hospitalized for 7 days. And he actually never made it to see us up in Boston. So the dilemma was that, he could sit there, with a laptop and so on, but the doctor in the emergency center in Florida needed access to his data back in Australia, his PCP, primary care physician, and a couple of specialists in Sydney, Australia. So, we've got the situation where he needed to explicitly give permission to those 3 guys in Australia to release data to a hospital and the selected specialist in Florida, right? So this is what that case is that diagram is referring to. The other use case that we're hearing, what I would call the .edu use case, is that so actually. To give you a real example, at MIT, we've just had this very successful mobile app competition. Basically, we're taking people who have 0 programming experience, giving them 3 weeks to write an app, either for Android or for iPhone. And we've got some pretty cool examples like find free food, meaning that find an event on campus that's big enough event that they'll have a table with free food and direct me there so that I can, on my way to my lecture, I can grab a sandwich and then go to my lecture. That's got some security implications, like you could turn that into a problematic scenario, but So we've got a growing number of apps being developed, and for each one of those cases, the students have had to go through difficulty in getting access to data. So, for example, if they wanted to access maps of buildings, they'd have to talk to the facilities people and so on and so on. So MIT and other universities are kind of slowly moving to this web API model, whereby you have all this uniform API out there. And depending on who you are, you can access data behind those APIs, but you need some access control regime installed that would allow you to allow the data owners, particularly MIT itself, to regulate access to the data. So that's the students' accessing MIT data. If you reverse that, again, you have cases where a student might want to give selected information about their scores at MIT to prospective, employers. Hiring season, they want to do that. Another one that we heard recently is there's actually a project being put through Internet 2 is a student that's going to enroll, that's going to try to apply to 5 different universities, creates an account on the College Board, and then he or she would like to have selected portions of their SAT scores available to these universities for a limited amount of time. So the user is actually proactively saying, yes, MIT can see this, Stanford can see this, Yale can see this, and so on. And it's going to be up there, the token, the auth token is going to be, valid for like a week. So that's the EDU, and it's actually, that second case is actually a real use case that is being written up as a grant proposal, and it's, when I heard it the first time, I said, gee, street identity technology is kind of needed here. And on top of that, something more complicated than just sharing SAT scores is also needed, particularly for the first EDU use case where you're actually sharing real data. We believe, UMA is a perfect fit. So anyway, good.
So just to put a little color on that, so what we're hearing is we've got individual use cases, truly user-managed access to data, offering that access to others so that we don't have to have a login to every system and be present to authorize. We're also hearing what I would call enterprise class use cases. Enterprises have long had these access management models that basically, constrain access, and you have a subject and a verb and an object, and you make policies, and you do all these things. What we're doing is a very lightweight, user-reachable method of same. And we're finding a lot of folks saying, I could use that in the enterprise. Like, let's say I want to use a bunch of cloud services, but I want those cloud services they're hosting data and services on the behalf of this company and its employees. I want it to call back actually to get authorization decisions from some authorization hub that I dictate. So those are some of the use cases we're seeing. So let's talk a little bit about technical details. We'll start to drill down, and then we'll show you a demo and ask questions or push back whenever you feel like it. So this is a sort of classic UMA architecture diagram for us. We've had it for a couple of years now. And so you've got an authorizing user at the top who is controlling access through an authorization manager as a kind of proxy. I said, a kind of power of attorney for the user. Protecting any number of protected resources at hosts, and those resources can be it's web APIs or just URLs that take you to HTML, whatever it is, or maybe it's identity claims. And so the user will be managing that information as they would. If it's photos they're protecting, that's the photo site that they like to manage their stuff at. And then you've got requesters. Now, you may be saying, well, this looks an awful lot like the OAuth participants. The participants in the OAuth dance, and you'd be right. So what you're looking at really is a slightly more formalized model where you've got enhanced versions of the OAuth resource owner, that's our authorizing user. You've got an enhanced notion of a resource server, that's our host. An enhanced notion of an authorization server, which is what we called authorization manager before they came up with that name when they did RAP and OAuth 2. And finally, a requester, which is a kind of enhanced client. Now, who's that guy at the bottom right, the requesting party? Why did we need him? Well, when you're sharing with arbitrary third parties, OAuth got away with not worrying about legal liability because it's Alice on both ends. Alice is permissioning access on Alice's behalf. When it's on Bob's behalf, well, maybe Bob is taking on some liability, and you want to make that enforceable. So that if in effect that person is clicking I agree, or that organization is clicking I agree, or maybe they're agreeing to keep this information under embargo or under NDA, or maybe they have supplied you a receipt for $5 that they've paid for this information. You want to know that you can sue them if something goes wrong. So we needed this model, and we have a trust model that takes into account not just the technical layer, but this kind of liability layer. Now, of course, OAuth doesn't say a thing about how the AS and the RS, the resource server and the authorization server, interact. So we had to solve that. We had to go there. We had to sort of figure out how to make them interoperable because we're centralizing the authorization server function. And so what we've done is we've defined a protection API that the authorization manager presents to any host. And guess what it's protected by, this API? It's protected by OAuth. So we have an embedded instance of OAuth that allows all these hosts to get introduced to the authorization manager and do things at that protection API wielding their host access token, which is just straight OAuth. You with me? We've found a lot of interest among some OAuthors just because they've wanted to separate these functions, and currently they're proprietary. And you do see a lot of deployments where you'll have a bunch of resource servers all calling back proprietarily to one authorization server, you know, in the back office. Like AOL might have 100 apps. I mean, you guys have this sort of the same situation. You're going to want your security token service, your authorization server, to be more centralized. And people tend to deploy it that way, and they've got some kind of proprietary stuff. We made it standardized. Now, when it comes to the actual act of requesting access, UMA couldn't use OAuth as written to solve the problem of not just, oh, we've got this API, we have developer documentation, we design scopes that sort of go with the API endpoints, but you have to look it up, it's not machine readable. We kind of had to make that all machine readable, and we had to prepare for it, not just something like one or a few endpoints. What if you had 1,000 photos and photo albums that you want to protect? OAuth kind of doesn't scale for that. So we went in a slightly different direction. And what we have is, it's more of a formalized token upgrade approach to adding permissions for some requester. So if a requester is approaching some host to get access to something that Alice controls, she's got lots of stuff there that she controls, that requester can go back again and again and prove that they're suitable for access to more than just maybe one endpoint or whatever it is. Maybe it's the next 1,000 photos. Okay. This is just a bit of a summary, and the PDF will be available if you care to stare at this, but we've been finding it pretty useful to convey the similarities and the differences between OAuth and OpenID Connect and UMA in this fashion. So really briefly, I mean, OAuth is kind of the core technology for all three, and UMA actually exploits OpenID Connect as an option for how does Alice write a policy that actually says Bob at Gmail is the only one who can get access to this calendar. Well, Bob has to prove that he owns Bob at Gmail. Well, guess what? OpenID Connect does that, so we use it for that purpose, and we'll see a demo of that. So a couple of quick comparisons. If you're not very familiar with OpenID Connect, what it adds to OAuth is that it is a single sign-on and identity and attribute sharing API that's meant to have a login session semantic on top of OAuth. The rest of these comparisons are with UMA and OAuth. So I can't actually see it very well. So this is, I've been saying Alice to Alice sharing is OAuth's wheelhouse and OpenID Connect's wheelhouse, and UMA goes Alice to Bob, Alice to Star, if you will. Next is the model by which you engage in privacy-enhanced interactions. It's not just a matter of consenting at runtime. It's a matter of setting up policies, which means that you're a more empowered offerer of data and service access. So that's actually a very big conceptual switch, and it's also a switch in the way the protocol works. In OAuth and in OpenID Connect, you kind of have to assume that the authorization server is local to all the resource servers you care about because it's proprietary. UMA has gone and defined that separation between the two servers, and also a way to introduce one to the other so that you can centralize it, which is big. OAuth, of course, works by, it's really authorization by authentication proxy, right? If an authenticated client approaches the protected resource, and a user that the protected resource knows says it's okay, you let them in. There's no opportunity for doing true claims-based authorization. By virtue of the separations that we've made and the way that you set up policies, an authenticated identity is just one kind of claim you can ask the requester to wield or prove to win permission for access. This is something I actually thought I'd never see in my lifetime. I was actually really against claims-based authorization as a concept because there was this, Kim Cameron would talk about it and he'd just sort of wave his hand around, well, authentication is just one kind of claim. And now I'm becoming a fan because now I see how it can actually be done using more modern technologies. Finally, OAuth really specializes in protecting web APIs. and OpenID Connect actually specializes in protecting identity claims. And UMA just says, whatever, if it's kind of web accessible, we protect it. Okay, on to demos.
Okay, so I wanted to present a demo of how the UMA works, what the user has to do in order to share data between a host and a requester, and what other users can do to apply for some access. So we will be operating on 3 different applications. So this will be very similar to street identity, but it will be, let's say, a slightly extended version. So we will show how we can share arbitrary data and how we can centralize access management for that data. So currently, I will show how I can share some data, and actually, I will show how I can share some data as a user Bob. So this will be sharing data between 2 different applications. As you can see, I'm logged into actually Facebook as Bob. And I will show how I can create some data on a host, and how I can actually then later access that data from a requester in a secure way. So there will be some authorization happening, and you will see that in the flow. There is actually yet another application called SmartIM, and this will be the authorization manager that actually manages how the host shares data with a requester. So let's go to a host. We simply have to log in with, in this case, our Facebook account. And we can see that there is some personal information that the user has on a host. So this is his full name and also birthday. And we will now, as the same user, log in to another application. So let's do the same flow. Let's log in with our Facebook account in this case. And this application should, get access to the data that we store at a different application. So we do not want to enter our name again and again. We don't want to enter our birthday information. Instead, we would like to simply grab it from the attribute provider, so from the host that has the data, and it should be the authoritative source of the data. So let's take a look what happens if we try to grab a name. For the moment, there's no discovery process, so please note that this is just a demo. We need to provide the actual link to the API which exposes that resource. If we try to fetch it, we don't have the permission to do that. This is because the resource, the name, has not been UMA enabled. It's not shared outside of the host application. So if we go back to the application, we can see that there's this share button. When we click it, we see that the host gives us an option to register with our application with any authorization manager, so a component that should take care of security of our data. For the demo, we will be using the SmartIM application. In this case, it could be a very similar user experience to what happens with the sign-in process right now, but for the moment, we're just inserting the URL of the application. And if we click Introduce, the application actually redirects us to the authorization manager and asks for some specific for a specific set of permissions. There's a very basic permission like know who you are at SmartIM, but also actually it asks for some UMA specific permissions. This is mostly the ability to register resources for protection, so what resources should be protected for that user. It also, there's also a permission for validating access to different resources and some additional ones. If we click on Allow, we get redirected back to the host. And now if we click share, we see that a resource has been protected, has been registered. So we know that whenever there's an access to this request, there will be an UMA flow executed for the user.
I want to make a quick comment. So in OAuth, you have this static developer documentation for those endpoints. What we've just done is dynamically register, think of it as an endpoint, a protected resource endpoint at the AM so it knows how to respond if some requester comes asking for that.
Yeah, so basically during that resource registration, what we did is that we taught the authorization manager what kind of a resource we have, what operations there are on this resource. So it's more of a dynamic way of telling the AM what kind of things it can actually protect. So if we go back to the requester application, and if we try to access the name again, what happens is that we get redirected to the authorization manager, which informs the user that this application is actually trying to get access to some data on our behalf. We can also see what kind of permissions it wishes to have to the data. We simply click on continue, so we approve such access, and what we see is that the data has been fetched from the actual host. If we again go back to a host and actually click on settings, we see that there's a new application which has been authorized to access that data. Also, if we go to the authorization manager and if we go to a history, we can actually see that we've accessed the data using a very specific application. So this was a scenario of sharing data between different applications, but we'll also show how you can share the data among different users. So I'll just switch to a different user. I'm logged in to Facebook as Alice for the moment. And I want to log in to the requester application. Again, I log in with my Facebook account. And I would like to get access to Bob's full name. So I would like to get this resource and to have this resource stored in my application. So I also click on fetch. Again, there's no discovery, so I need to provide the URL. But if I click on fetch, and this resource, as we know, is protected, is that I get redirected to the authorization manager, which tells me that the application that I'm using tries to get access to some protected information. However, I do not have access to that information because Bob did not authorize such access. However, I can actually request access to the data. So I click on continue, and the requester application informs that such access request has been recorded. If I go back to the to Bob, so to user Bob, and if I clicked on my shared data, I see that there's my name. I see that no one has been authorized yet, but I see in here that there's an access request for the data. So I click on grant access. I select permissions that I would like to apply for this particular individual. I click on confirm, and there can be some notification for user Alice. And if user Alice goes back and tries to fetch the resource again, you can see that she gets access to the resource. I'll also show how this happens once you pre-establish a relationship. So if you define sharing settings in advance. So let's go back to user Bob. We can again maybe register a new resource. Let's register the birthday information. Let's go to settings. Let's add some people. Let's add Alice. Let's select the application that she can use to access that resource.
Where did that list of
So for the moment, you can either create contacts by yourself, which means that the OpenID Connect flow comes in, but you can also integrate with such services as Facebook or Google.
I think it's worth pointing out, so Smart AM is an actual implementation. It's made implementation choices and providing some very nice features like the notification that somebody tried to get access. The generic sort of UMA protocol underneath doesn't really know about all that stuff, but it does know that you're going to apply policy and whatever the AM offers as policy choices. So ACLs would be a really good one by email address. That's why OpenID Connect is so powerful, because it helps you prove an email address, among other things. Yeah.
So I don't think we will actually have time to show the OpenID Connect flow, but what you can do with Smart AM as well is that you can just define a policy that a specific user with this email address should get access to a data, and then the authorization manager requires you to provide a claim that you really have that email address. So otherwise, you need to log in to the authorization manager. So let's just again add this person. We can see that birthday has some authorized contacts. There's Alice. You can see the permissions that she can use this application. You can see the permissions for this application for Alice. And if we go back to Alice and if we try to fetch birthday, then you can see that access is immediately granted. So there's obviously a lot of, or maybe not a lot of, but few calls in the back channel that you don't see, where a requester tries to get the access to the resource and eventually has to upgrade the token to get access to this resource. And only then the host would release the actual resource to the requester. What's I think worth noting is that if you go to the authorization manager and you can see that the resource is protected. You can actually also see all your contacts, and if you click on a specific contact, you can basically see what kind of resources it can access. So you immediately see, you centralize the way you grant access to different data. The other thing is this history where you see how people would access the data, since the authorization manager knows and can record when the host asks for what kind of permission is associated with a particular token that it gets from a requester once access request is taking place. Yeah. So are there any? Authorization manager, or yeah. To the data.
Yeah, sure. You want to repeat it? Or?
Yes. So the question was whether if an attacker compromises one of the systems that we have, for example, the IDP or the AM, so the authorization manager, whether this would give the attacker all the access to the data. So for the moment, the AM, it is a single point of failure. Basically, what we implement is that we base our system on, let's say, bearer tokens, and these are tokens which get fully generated by the AM, which means that, yeah, if the attacker can get access to the tokens, it will eventually get access to the data.
Let me comment on that a little bit. You're right about that, and really, if you compare apples to apples with OAuth today, I mean, if your time to live strategy around your token length validity is really long, as it often is with native apps, you're kind of hosed, and we should stop doing that, actually. But the good thing about the OAuth pattern that we're using is that you can revoke access by one sort of channel if you discover it's rogue, right, without disturbing some of the others, and that's one of the benefits. So it doesn't actually, you know, if any of the systems that you're using, if you're logging into an AM with just a password, for example, and you know Bob is logging into some other system with just a password, you're subject to all the phishing problems that you might have otherwise. Any kind of redirect protocol is going to be susceptible to that. It kind of argues for strong authentication and some of the more, you know, esoteric identity assurance standards, and that's actually one of the things that we hope to be kind of mixable with. We've often said, we don't want to boil an ocean, we're just boiling this small pond, and we're actually relying on a bunch of other work, like some of the trust framework work, for example, where you could actually set policy to say, Bob has to log into LOA2 strength, and now all of a sudden, maybe it has to use Google Authenticator or something. And you don't have to necessarily know how to do that, it's just that the token that comes in has to prove that it's that strength. So I often think of the former congressman from New York who had the verified Twitter account where I'm sure he proved he was really the congressman when he got the account, but it's just password protected, so it means nothing. So all those things get, their reach gets amplified by this. So if you actually trust an issuer to say, this is a citizen of the UK and only citizens of the UK can get access to this information, if they spoof that issuance, you're still hosed, but at least you can turn it off if you discover it. You can also perhaps sue who it was because of the trail, the audit trail that you've got. Say that one more time. Yeah, so right, law enforcement access. So one of the things about UMA is it's a discretionary access control system. If somebody gets a subpoena and goes through a back channel to get to your data, UMA's not kind of involved in that. The same as, anybody using, let's say, your average WAM system today, if they get subpoena, they have to cough up data that their policies never said they were supposed to reveal, right? Cool. Should we move on? Do you want to plug in this one again? Oh, is it? To the next couple here.
So actually I need to acknowledge the work that others done on this project. So this implementation of the applications in the Smart IAM. So this is the these are my colleagues at Newcastle University. Let's say at the peak there were the team had 5 members, but currently there are 3 active members working on this project. Again, this is just a recall of the scenario that we had for Smart IAM. So there was a host that had the data, the requester that was aiming to get access to the data, and the Smart IAM, which actually centralizes how the data is released to different requesters. And we used Facebook as the identity provider for the moment, but it was still brokered through a component called Social Connect, which integrates well with Smart IAM and aims to provide, let's say, a more seamless user experience. Otherwise, establishing every relationship requires, quite some effort. But if the IDP integrates with the AM, and in this case, if there's a broker that integrates with the AM, then the process can be slightly simplified.
I think we could probably go a little bit faster through these spell check.
Okay. Yeah.
So just to let you know of a couple of other implementation efforts that we know of, we've got folks who are at the UMA table working on this. One is by Fraunhofer ISAC, and they're using as an example, they're using a photo sharing model. And I think they're planning to open source that work. And is it .NET based in that case? You've got Python and Java implementations that you're planning to open source. They've got a .NET implementation they're working to open source. And then a fourth implementation is involved with some work in the EU that's called Task 3. Actually, the new name is End-to-End Trust Assurance. And the idea with the base of that is that users should be able to audit access that was made to their stuff. But more than just audit, they're actually putting in this Summa Connector so users can put in place policies and actually control it and not just audit. Why UMA enable? So shall I just run through this and you can sort of fill in? We wanted to sort of give you some food for thought since you guys create apps, since you run an identity provider. For starters, every web app that gets stood up today, pretty much, it doesn't do its own billing. It outsources it to Chargeify. How much cooler could it be if you could also outsource all the user sharing preferences kind of setting stuff to a central authority that you trust to do that? It gets you a lot of probably liability protection, sort of privacy check marks, all kinds of goodies like that. And it takes away some functionality that would have been hard to do. This is why we're seeing social sign-in today, because authenticating is a kind of thing that you'd like to outsource, and people are doing that. So you can provide sophisticated protection and sharing, not just sort of cobbled together protection and sharing that's only good for your app. You can actually leverage the work done by others. You can ensure that the protection of really sensitive stuff is not stupidly protected with secret URLs. You can build trust more readily with users, and we're trying to make it as easy as possible to integrate these features, not using kind of the heavy WS star methods of the recent past, but rather, things people like to use, at least to a first approximation. Why, if you're an identity provider, should you care about this stuff? Well, we're now seeing with OpenID Connect and Street Identity and NSTIC, the National Strategy for Trusted Identities in Cyberspace, and other similar efforts, we're seeing this notion of attribute providers as first-class citizens as they should be. And we're finally getting some tools for doing something interesting with that. So if an IDP wants to remain higher touch than ever, wants to provide more services than ever, but couldn't possibly be the native authoritative repository for every piece of data, every service of interest to a person, this is a way of doing it. OpenID Connect is a nice adjunct, obviously. Google is working with the OpenID Connect folks, and it seems like it's going in that direction. UMA provides all these complementary pieces of functionality, Alice to star sharing. We see opportunities with trusted attributes, user-generated content, APIs, whatever it is that you want to share that's on the web. So we'll just conclude now with a reminder that we've got the tweet chat coming up, and if you're willing to stay, we can take questions. I think we're good till even 4. We can hang out here. Any other questions, comments, interest, jumping on board, deploying? Yes? How could this be a service? How can the authorization page, how can the AM be a service that really works? This is actually the first question that we've run into since the very beginning, which is, isn't the user experience going to suck, basically, in a nutshell? And one of the things you'll notice about the flows we just showed, even with street identity, is it involves a lot of logging in and permissioning, right? The login and consent flow is not something you really want to do more than once in a sitting. And we're constrained to be doing that for now until the discovery and introduction piece gets a little bit better. But the HData, that Project HData flow that we showed, I know it was a bit of an eye chart, but projecthdata.org is a real thing. It's primarily run by MITRE. It's an HL7 project, and they have this problem of they're building a RESTful API and a data format, it's actually an XML data format, for health records. They have a component in their architecture that they call the DAS, which is the Discovery and Authorization Service, which if you remember old Liberty Alliance days, there was always this discovery service, sometimes called DISCO. Once you have the ability to register things with the AM, there's a lot of things you can start to do silently. And once you have the ability to set policy, once a person has the ability to set policy, there's an opportunity to shortcut all of those logging ins. The kind of thing that Maciej was showing had a lot of sort of smart AM specific optimizations. Essentially, if you want to collect trusted claims or any claims at all from the requester, the requesting party, think of it as them having to log in to the AM and provide data, right? So they're kind of having to do a login if you want to think of it that way. Really, the more important way to think of it is if they want access, they got to cough up some claims, and this is a way to get the claims, right? So I kind of don't care about the requester's process for what they have to do. And what we'll work on next, we've got human operator of a requester app flows, and the next thing will be web service operated, autonomous web service flows, where a requester is just a web service, maybe it's a crawler. Oh, I found your demographic data off of your site, can I get to it? Well, if you pay me $5, yeah. So the experience that the user has, we acknowledge there's opportunities for a lot of optimization, and I know how hard it's been even to get to the NASCAR stage and the account chooser stage. So that, I think, is really nascent even in the authentication world. So I acknowledge that that's definitely something that needs work, but I think if the value is there, we'll get there. Do you have a comment on that before, and then we'll go to you?
Yes. Actually, yeah, maybe one more comment to this. Like if the ADP would be extended, let's say with the AM, the entire process would be really greatly simplified. I understand that the approval page is a huge problem in here because it has to, show lots of different informations. Like if I, as user X, want to get access to some other guy's data, then you need to provide some more information than what's at the current approval pages. However, we tried to insert this some sort of a broker again between the IDP and the AM that we have right now, because previously when we only had a separate components, like the IDP was a separate component, the AM was a separate component, we would get through a lot of different approval pages, and these were very problematic for the users. Now we are able to basically issue, if the application decides not to use, for example, an IDP directly, but to use it through our proxy, it actually gets a token that's powerful enough to be executed against the AM as well, which means that, it's a sort of a nice user experience. It gets much better actually, and much easier for user to understand that he's just giving access to one more service, and then the user doesn't really need to know that if he presses share that there's some information flowing to the AM. You immediately get redirected, for example, to some sort of a page where you can set policies. So it's very much simplified if you can insert some sort of or if you can connect the IDP with the AM either through a broker or directly.
One last thought. I'm sorry to delay getting to your question, but there is an opportunity, and this is another one of those we're boiling a small pond, not the whole ocean kind of thing. There's an opportunity when you have standardized APIs and standardized scopes and standardized claims for more standardized user experiences around those. And one of the things we had to invent was, we call it scope metadata, I think, and it's basically a kind of machine-readable description of scope. Oopsie, what did I just do? Sorry. It's kind of machine-readable scope descriptions, configuration data, if you will. And it's just a simple little JSON thing. It's not very exciting, but it's tantamount to like it's the first thing you'd want in API developer documentation. Like what's that? Is it Swagger, that cool sort of annotated RESTful API documentation that you can generate? Is the second you get it machine readable, you can start to have standards. And at first we thought, well, we're just going to be very pure. We said we have to be RESTful, and the only kind of API we're going to support in UMA is, RESTful CRUD, or like, get, post, put, delete. Well, that didn't last because, the world runs on proprietary APIs that are providing added value. You can't dismiss that. However, once you have the ability to describe your scopes, you're on the way to, and we allow for this in UMA, a host choosing to implement a standardized API and pointing off to scope descriptions that don't live with it. And that presents the opportunity for standardizing the interfaces for checking off things and doing policies around them. The same as with OpenID Connect and the opportunity to standardize claim URIs so that when you say birthday, you mean that kind of birthday and not something weird. It's kind of successive approximation around standardizing those things, and UX opportunities come along with those levels of standardization. That's my hope. We tried to standardize that and totally failed. So and I know that the entire OAuth universe was burned by the scope conversation, right? All right, they're just comma-separated strings, and that's what they thought was good enough. We actually determined that wasn't quite good enough, but scopes can still be anything you want. You just have to kind of register them.
So here's an idea.
Yeah. Yes. Yes. Let me repeat that. So the idea is that you can sort of subscribe to standardized policies that the EFF came up with, for example. So right now, the way we've defined the AM, it's unlike the more sophisticated enterprise systems like, Xacml or something, where you have a standardized way of going and looking up federated policies. We don't have that because it's all currently internal to the AM. So it's a policy administration point, it's a policy decision point, it's a policy information point as far as anyone's concerned. Those APIs, it could become a client to an API that serves policies, and we haven't gone there in V1. I would love to go there in future. Yes. Absolutely, yeah. Then you can start to do, I mean, this starts to make kind of big data around your own stuff doable for a person, with the right API. So I'm very excited about all those possibilities, and thank you.